special type of motion is called free fall. An object is free fall if the only force influencing its acceleration is the gravitational pull of a nearby surface, usually a planet. One example occurs when we throw or drop a ball. It is usually the case that the ball's acceleration is only due to the force of gravity from the Earth. The strength of this force is often given as -32 feet per second squared, or -9.8 meters per second squared. Another example of free fall occurs when a space probe is allowed to crash into a planet, with no attempt made to slow its descent. Here the only force impacting acceleration will be the gravity of the planet. The value of this gravity will depend on the planet. In a physics class, students often learn many special formulas for displacement and velocity of an object in free fall. All of these formulas can be shown using calculus. For instance, for a falling object with height measured in meters and time is measured in seconds, the formula for change in velocity over t seconds is equal to -9.8 times t. In calculus language, we would write this as v of t minus v of 0 is equal to -9.8 times t. Let's see why this formula is what it is. The first important fact is that acceleration is the derivative of velocity. So we can apply the net change theorem to see that v of t minus v of 0 is equal to the definite integral from 0 to t of a of t dt. For an object in free fall, a of t is equal to -9.8 meters per second squared. So we plug that expression into a of t, giving v of t minus v of 0 is equal to the definite integral from 0 to t of -9.8 dt. We can evaluate this definite integral with an antiderivative, which will be -9.8 times t. Plugging in and evaluating, we get v of t minus v of 0 is equal to -9.8 times t plus -9.8 times 0. This simplifies to v of t minus v of 0 is equal to -9.8 times t. Notice that you might see this formula in a few different ways. For instance, we could add v of 0 to both sides to obtain v of t is equal to -9.8 times t plus v of 0. Often people use v sub for final velocity and v sub I for initial velocity. In that notation, we would have v sub f is equal to -9.8 times t plus v sub I. Regardless of the letters you use, the important thing to know is that this formula just comes from basic principles we have already seen, including definite integral formulas. If you were to ever forget a physics formula, you can come up with it yourself using calculus.